Hello students, myself Vijay Lakshmi Sugnalli and you are watching my channel where I upload videos for 2nd PUC Mathematics NCERT. If you are preparing, then my YouTube channel is very helpful for your annual exam. So students, I upload videos here. Do watch and subscribe my channel Win Maths. Here in this session we have to study the linear programming problems, okay, that is LPP. Okay, here this is the one of the important chapter. This chapter carries one question for 6 marks in part D section. Okay, in part D section there is a two questions are there for 6 marks. In that two question, one question will be asked for linear programming concept, that is linear programming problem. We already know the concept, okay, because we know about the graphs or draw the graphs. Okay, here we have discussed system of linear equation and their application in day-to-day problems. In class 11th we have studied linear inequalities and system of linear inequalities in two variables and their solution by graphical method. Already we learnt in first year and also we draw the graphs also. Okay, here so many applications are there about linear programming. Here in this chapter we shall study some linear programming problems and their solution by the graphical method only. Through there are many other methods also solve such problems, but here we have to study only graphical method. Here mainly there are some wordings are there. Okay, here there are some points or some wordings we have to use here, that is feasible region. Okay, feasible first one point, then feasible region, feasible solution, next optimal value and optimal solutions, bounded, unbounded. Okay, these are the wordings we have to use in the chapter. Okay, here mainly in last year we have to solve the system of linear equation of two variables, that is if all the if we have two equations such as the equation of the form a1x plus b1y is greater than or is equals to c1, or a2x plus b2y is greater than c2, and similar like this. By using the xy plane we have to draw the graph. Okay, this is the x plane and y plane. By using the equation we have to draw the graph by taking the x and y values. Okay, here also we study the same method, but we have to draw the graph in that same manner. After draw the graph we have to check some points here. Okay, here we study only the equations. Okay, here optimal. Okay, here optimal value means for it may having maximum value or minimum value. Optimal value means it is maximum or minimum value. These type of problems are called as a optimization problems. That is what I mean by the optimization problems means the problems may involve finding maximum profit by using the minimum cost as well as by using the minimum resource for getting maximum profit. Okay, what I mean by the optimal problems or optimization problems means getting maximum profit by using minimum cost. Okay, optimal value means getting maximum or minimum value by using the variable x and y. Okay, here then optimal solution, when we substitute x and y points in the equation, that is in that case we have the solution that is called optimal solution. Okay, then feasible point, when we draw a graph. Okay, when we draw a graph on the x and y plane, the points which are present on the line are called as a feasible points. Feasible region means the common. Okay, feasible region means the common region between these two lines. When they given two variables or two equation, there is a common region between these two lines. That is, this is the common region. That the common region between the two lines is called as the feasible solution. Okay, then feasible region, when we take the points on the common region, the coincident points of the common region or the points which are taken from the common region, we getting the result or solution that is called the feasible solution. Okay, then feasible solution, every point of this region. Okay, next bounded means the common region which is covered by the feasible region. Okay, the common region which is covered by the corner points, that is called bounded. This is the region is covered by the corner points, that is called bounded. Then unbounded means the region not covered by the corner points, that is called as unbounded, because here only 3 points, there is no outside points which are not covered by this region, that is called unbounded. Okay, that is called unbounded. This much you have to remember. Okay, that is okay. First one is have to write the one point on this one. Okay, then here another one point, that is constraints. Okay, that is constraint. Constraint means the variables. We have to take the variable means or alternative, the name called constraint. The variables are called as a constraints. Okay, the next first point is simply I am writing the one point, that is feasible point or feasible choice. Feasible point or feasible choice, that is the each point in the region. Okay, the each point in the region. Okay, each point in the region are called as the feasible point. Next, and the point feasible region. Okay, feasible region, that is the common. Okay, visible region means the common point between the, that is the common region, the common region determined by the all the constraints, all the constraints including non-negatives. Okay, including non-negatives constraints. Okay, including non-negative constraints. Mainly we have to study the linear programming problems while x is greater than or equals to 0, y is greater than or is equals to region. We have to study the linear programming problems on the first quadrant only. We have to study all the values in the first quadrant also, because in this quadrant x is greater than or is equals to 0, y is also greater than or equals to 0 means x and y values are positive, so we have to getting the maximum value here only. That's why we have to consider only the first region, okay, or first quadrant. Then feasible region or another one point, this is called as the solution region also. This one is called solution region also, the another one name for feasible region or solution region, that is the shaded region of the common point of LPP. Okay, here invisible region, the next point, invisible. Simply what we say, invisible region other than the visible region. Okay, the region other than the visible region. It means visible region ಬಿಟ್ಟು ಉಳಿದಿದ್ದೆಲ್ಲ ರೀಜನ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಇನ್ವಿಸಿಬಲ್ ರೀಜನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಆಪ್ಟಿಮಲ್ ಸೊಲ್ಯೂಷನ್. ಓಕೆ, ಆಪ್ಟಿಮಲ್ solution. Optimal solution means any point in the feasible region. Okay, any point in the feasible, any point in the feasible region, any point in the feasible region that gives optimal value, that is optimal value. Any point in the feasible region that gives optimal value, it may maximum or minimum of the objective function. Okay, objective function. When I am solving the problems, it will clarify. All definitions will clarify for you. Okay, then bounded. Okay, what is the bounded? Bounded means the feasible region, the feasible region within the space, the feasible region within the space, that is called bounded. Okay, then unbounded. Last one is unbounded. Okay, The last point is unbounded. The region not having corner points. Not having corner points. Okay, the region not having corner points are called as the unbounded. Okay, another one point, if R is unbounded, then maximum or minimum value of function may not exist. Okay, may not exist. Minimum and maximum values may not exist. Okay, the region not having corner points, if R is unbounded, then maximum or minimum value of function may not exist. Okay, up to this much the points are over. Now another one point, the method of solving the LPP. Okay, here there is a method how to solve the LPP. Okay, that is method of solving LPP. Method of solving LPP. Okay, first step. Okay, or method. Usually we have to solve the LPP by using corner point method. Corner point method. Usually we solve the LPP by using corner point method or system of linear using the graphical method. The first point. Okay, here there is a first point, find the visible region. First one, find the visible region of LPP and determine the corner points. Determine the corner points by solving the equation of line. Okay, here first one method is have to solve the system of equation of lines. Okay, then have to find the x and y, that is corner points, and to draw the visible region. First have to solve the equation of line, then find the corner points. When taking x is equals to 0 we get y value, when y equals to 0 we get x value, and draw a graph of given equations. After that, finding the visible region, that is shade the region which is common to both the line. Okay, after that evaluate the objective function. Second, evaluate the objective function, that is evaluate objective function, that is z is equals to ax plus by at each corner point. At each corner point. At each corner point. Okay, Here evaluate the objective function z is equals to ax plus by at each corner point and find the maximum and minimum value. Find maximum value m, capital M, and minimum value small m respectively. Okay, find the or choose the maximum value and minimum value while getting the adjective function. Okay, then after that, if the third point is if the visible region is bounded, we get maximum or minimum value. Okay, if third point, if or if visible region, if visible region is bounded, if visible region is bounded, we get maximum, or minimum value. If visible region is bounded, we get maximum or minimum value. Otherwise, there is no maximum and minimum value. That is, if visible region is unbounded. Therefore, otherwise, when visible region is unbounded, when visible region is unbounded, there is no maximum, or no minimum value. Okay, when visible region is unbounded, there is no maximum as well as no minimum values. Okay, these are the method of solving LPP. Step one is the find the visible region of LPP and determine the corner points by solving the equation of line. Then evaluate the objective function z is equals to x plus by and each corner point find maximum value and minimum value. If third condition is if visible region is bounded, if we get maximum or minimum value. Otherwise, the visible taking equation 1. Now take one box. Okay, taking the values here. First x, y I am considering for this equation. Substitute x is equals to 0 in equation, we get y is equals to 50. And again substitute y is equals to 0, then we get 50. Okay, now again consider the equation 2. Here considering equation 2, that is 3x plus y is equals to 50. Here also I am taking a box the points. I have considered x, y. First put x is equals to 0 in this section, y is equals to 50, and again put y equals to 0. What is the x value? Y equals to 0, that is x is equals to 50 by 3. Okay, 50 by 3 have to subtract by 3. 3 ones are 3, 20, that is 16. It is nearly 16.6 something. Okay, that is I am taking 50 divided by 3. Okay, here otherwise I consider these two values. Now I have taken graph. Okay, I have to draw a graph here. Simply I am taking a rough diagram here. Okay, after that I will place in a actual graph. Okay, here sorry, here I am considering a wrong value. Here I am considering the graph. Okay, now first simply I am taking a rough diagram for explaining the graph here. Okay, this is y-axis as well as it is x-axis. Okay, here first have to check the units. X are the 30 and y is equal 90. Here 50 50, all units are in 10 digits. So first have to write the scale. Okay, what is the scale? Taking x-axis, that is 1 unit is equals to 10 centimeter because we have values in tens, and y-axis 1 unit is equals to, here also I am taking 10 centimeter. Okay, now first here in the x-axis the largest number is 50. So 10, 20, 30, 40, 50 and 60. Okay, now here 90, the largest one is y-axis 90. So we have up to 90. 10, 20, 30, 40, 50, 60, 70, 80 and 90. Okay, that is okay. Here x is greater than 0, y is greater than 0 means always we have graph in only for first quadrant. Here only we have the graph. Okay, now have to draw a graph here. First I have draw for the first equation. Here x is equals to 50. First mark x on x-axis, this one the point is. Okay, again then y point is x is equals to 50 when y is equals to 0. This is 0. Again y is equals to 50. Okay, y is equals to 50 when x is equals to 0. Okay, here so have to first draw the first diagram. Okay, then here first have to take the shading part. For the first graph I have shaded the region. Okay, because there is no confusion for us. Again I am taking the second one part. Here x is equals to 0 when y is equals to 90 degree. Here I am taking graph point and y is here y is equals to 0, x becomes 30. There is a point which is lies here. So I have to draw this one. Okay, here I am shading the region. I am taking another one color for now because for understanding purpose. Okay, what is the region? This is the region here. Okay, now what is the common region? Okay, what is the common region here? This is the common region for both the graph. So this is our visible region. Okay, this is our visible region. That is, have to consider the points Here I am taking from this one. Here it is a point A, and this is the common region, the point B. Here we getting coincident point, that is C, and here D. Okay, the here I am have to plot the graph here. After that we have to consider, after drawing the graph, have to write one point here. Okay, after graph have to write one point, the shaded region or feasible region is surrounded by the corner points that is A, B, C, D, A. Okay, this is the surrounded by the region. Then the feasible region is bounded. The feasible region is bounded. The feasible region is bounded. Therefore, we get the maximum and minimum point here. Okay, I am considering the corner points. Here the first corner point is, that is A comma, here 0 comma 0, A point. For this one, x is equals to 0 and y is equals to 50. Okay, the point is x is equals to 0, y is equals to 50. Here have to cut the point. Okay, have to cut the point, taking here x is 20 and y is 30. Okay, the point where the point meets, so have to draw a line for y-axis as well as axis. We get C point 20 comma 30 and D point 0 comma, here x-axis is 30 degree, so 30 y-axis is 0. Okay, the corner points. For these corner points, we have to calculate the maximize. Okay, here we have to use the objective function. So after this one, here I am writing corner points and z is equals to 4x plus y I am taking here. Okay, that is the shaded region or feasible region is surrounded by the corner points A, B, C, D, A. The feasible region is bounded. The feasible region is bounded. For the corner points are, consider A is equals to 0 comma 0, B is equals to 0 comma 50, C is equals to 20 comma 30, and D is equals to 30 comma 0. For this point, we have to calculate the objective function. 0 comma 0, put x is equals to 0, y equals to 0, we get 0. Again for this one, put x is equals to 0, y is equals to 50 in this equation, we get 50. Again substitute x is equals to 20 and y is equals to 30. 4 into 20, that is 80. 80 plus 30, that is 110. And for x is equals to 30, 4 3 is a 12, that is 120. At point 30, it is 120. Okay, when they are given in question, solve the following LPP graphically and we get maximize. So in this point where it is maximum value, it is maximum at 120. Okay, maximum at 120. Therefore, we have to write the last point, that is conclusion is, okay, here the conclusion is, hence the objective function z is maximum at point D 30, 0 is 120. Okay, hence the objective function z is maximum at point 30, 0 is 120. Up to this much the solution is completed. Okay, once again we have to check the problem. First have to solve the following LPP graphically. Check first, have to keep constant as objective function. For the subject to the constraints equation, we have to draw a graph, solve the points while taking x is equals to 0 and y is equals to 0 for each equation. After that have to draw a graph, and for that points again we have taking the common region for the both graph. For that common region we have to choose the corner points. After that, for that corner point have to write one point. The shaded region is visible region is surrounded by the corner points, have to write the corner points. After that, write it is bounded or unbounded condition. For bounded region have to check the corner points. In that corner point, if they given maximum, have to choose maximum, or sometimes they give minimum, that time have to choose the minimum point. For that one, then we have to write the conclusion part. Okay, up to this much it carries 6 marks. Okay, now we have to check the exercise problems now. Okay, now I have solved the exercise problem. First one, I have taken one exercise problem, that is question number 1. Okay, have to check question number 1, the exercise. Okay, I am considering another one example problem. It is also one of the important problem. Determine graphically the minimum value of the objective function. Have to check the minimum value. Okay, here we have to check the minimum value for the objective function. Here, subject to the constraints, that is 2x minus y is greater than or is equals to 5, 3x plus y is greater than or is equals to 3, and 2x minus 3y is less than or is equals to 12. Here they given three conditions. Then x is greater than or is equals to y and y is greater than 0. Okay, have to check the graph for three equation. First I am considering 2x minus y greater than or is equals to minus 5. So taking x and y, put x is equals to 0. Okay, put x is equals to 0, minus y is greater than or equals to minus 5. So y is equals to 5. Again, put y is equals to 0. Then we get x is equals to minus 5 by 2. Minus 5 by 2 means, that is minus 5 by 2. Minus 5 by 2 divide by 2, it is 2.5. Here there is a minus symbol, that is minus 2.5. X is equals to 0, we get y value 5, and y is equals to 0, we get x is equals to minus 2.5. Again I am considering this 3x plus y greater than or is equals to 3. Okay, then here 2x minus 3x plus y greater than 3. So have to check the value x and y. Okay, put x, y x is equals to 0, we get y is equals to 3, and y is equals to 0, x is equals to 1. Okay. Next, 2x minus 3y less than or is equals to 12. Then have to check the values. Okay. Here put x is equals to 0. We get 3 minus 3y is less than 12. Okay, taking minus on this side, it that is 3 is equals to minus 12, x comma y. Put x is equals to 0, then y is equals to minus 4. We have to solve. So it means minus 3y is equals to 12. Then 3 ones are 3 fours are y is equals to minus 4. Again put the y is equals to 0. We get x is equals to plus 6. These are the values. Now have to draw a graph for this one. Okay, I am taking graph on the graph sheet. Okay, I am considering the graph for this one in graph sheet. Okay, here all the values whatever I have taken are in one unit. Here x is, compare all, x is maximum at 6 and y is maximum at 5 and minimum at 4. Okay. Here first I have to consider okay. This much portion is enough. Okay, here there is a point 0, 0 at origin. Here x is maximum. How much? 6 units. 1, 2, 3, 4, 5, 6. This much is enough. And here 1, 2, 3, 4, 5. Okay, 6. Here 5 and 6. This much is enough. Now have to, here there are some negative points are there, so I am considering here minus 4, that is minus 1, minus 2, minus 3, minus 4. Here also minus 2.5, so just here minus 1, here minus 2, minus 3, here minus 2.5 is okay. Okay, this is x-axis, y-axis. Okay, have to draw for now. X is equals to 0, x is equals to 0, y is 5. So point is taken here, and when x is equals to 0, then y is equals to 5. I am taking here. When y is equals to 0, x is at minus 2.5. Here I am taking and drawing the graph now. Okay, here there is a point. Okay, here we have point here, but x is greater than 0 and y is greater than 0. It means have to place the graph in first quadrant only. Don't consider these points. So have to extend these points here. Okay, we have to draw only in positive axis only. So don't consider this part. Again I have drawn here. Okay, for this much, and again draw for second one. Here x-axis is 0, then y becomes 3. Here there is a point. Again y is equals to 0, x is 1. Here there is a point, so have to draw here. I have to draw here now. for the third one. Okay, x is equals to 0 and y is equals to 6. X is equals to 0 and y is equals to 6. Okay, here x is equals to 0, y is equals to minus. That is in negative axis. I am not considering. Just I am taking y is equals to 0 and x is 6. That is here. Y is equals to 0 and x is equals to 6. Okay. Here there is a point 4 here. So I am not considering draw there is a line. So I will extend only here. Okay, don't consider this point. Here we have the graph, that is this much. Okay, here check the diagram. Okay, there is no visible region. Okay, here there is no bounded region because here the only points are coincide, but we have not taken because we have only positive values, but here the coincident point is negative, so don't consider. Here also there is a one point. Okay, so this point is also not considered, so the region is not bounded. Okay, the common region is, this is the common region. Okay, this is the common region, but there is no points are not considered. Here have to check these. The graph 2x minus y is greater than or is equals to 5 means the value we have considered. Greater means always have to draw on right side of the graph. Greater symbol means have to draw or have to share the region on right side. If here also I am taking 3x plus y, this is also the line, this one I have taken right side of this graph. Here 2x minus 3y is lesser condition, so for this lesser condition we have to draw a shaded region on the left side. If the less condition, less than or is equals to condition, we have to shade the region when we plot graph that left side. Greater means have to right side. Okay, so there is no bounded region here, it is unbounded. Have to write the scale here. X axis is equals to 1 unit is equals to 1 centimeter and y axis 1 is equals to 1 unit is equals to 1 centimeter. Okay, therefore it is not a bounded region. Okay, therefore there is no maximum and minimum we have. Therefore we have to write one point here. For this graph I have taken the graph here. Okay, I have taken graph here. Now I am writing the points here. Let all the let all the points on the corner region is not bounded. Okay, therefore the visible region, therefore the visible region is not visible region is unbounded. The visible region is unbounded. We have to consider the corner points. Okay, the corner points. What are the corner points here? I am taking the corner points. This one, that is x axis is here. The x axis, x is 6, y axis 0, and there is another one point here I am considering. This is A point, this is B. Here x-axis is 1, y is 0, and 1 here x-axis 0, y is 3, and there is a 1 point x-axis 0, y is 5. C and D, the corner points. The corner points and objective function z is equals to minus 50x plus 20y. Okay. Here we have to check the value. A equals to 6.0, B is 1.0, C is 0.3, and D is 0.5. Have to check the objective function. Here z is equals to, put x is equals to 6, we get minus 300. Again z is equals to, x is equals to 1, minus 50. Then z is equals to, put x is equals to 0, y is equals to 3, that is 60. Here z is equals to, put x equals to 0, y equals to 5, that is 100. Okay, here there are two minimum points are there, so we can't say which is the maximum. Okay, we can't say the maximum or minimum. Therefore the feasible region is unbounded, hence there is no exact minimum value for objective function. There is no exact minimum value for objective function. This is the solution for unbounded condition. When they given bounded condition, we have to say directly it is maximum point and minimum point. But when they given unbounded region, or when we get unbounded region, we can't write any maximum or minimum value. Okay, up to this much the example number 4 is completed. Now here exercise 12.1, the first question, maximize the objective function z is equals to 3x plus 4y subject to the constraint x plus y is less than or is equals to 4. So we have to consider the equation x plus y less than or is equals to 4. So we have to check the point x and y. Here put x is equals to 0, y is equals to 4. Again put y equals to 0, x is equals to 4. Okay, this is the simple one. Just I am taking the rough graph paper here, that is we have only 4 points, so I am considering only 4 units here, that is x axis and y axis. Okay, 1 2 3 4, 1 2 3 4, here 0 1 2 3 4 5, 1 2 3 4 5. Okay, simply I am consider. Okay, x is equals to 0, then y is equals to 4. X is equals to 0, y is equals to 4 here, and y is equals to 0, x is equals to 4 here. So have to draw a line. Okay, here there is a less than or is equals to condition. When less than or is equals to condition, we have to draw a line. Then for that line we have to shade the lesser condition, that is here the shaded region. Again they given another subject to the constraints are x is greater than or is equals to 0, y is greater than or is equals to 0 means there is a positive region. So the corner points are here. There is a corner point, that is x is equals to 0, y is equals to 4, and here y is equals to 0, x is equals to 4, and y is equals to 0. When we return the x and y values, first have to write x, later y. Okay, here there is a one corner point 0 comma 0. This is the bounded region. Okay, the feasible region. The feasible region, the corner points I have considered A, B, and C. The feasible region A, B, C, A is bounded. The feasible region is bounded. Therefore, we have maximum or minimum. Here the corner points. The corner points and z, the objective function 3x plus 4y. Okay, the corner points and the objective function. Now we have to check the corner points A, that is 0 comma 0. Now B 0 comma 4, C 4 comma 0. Have to check here the first condition 0 comma 0. Put x equals to 0, y equals to 0, we get 0. Again put x equals to 0, y equals to 4. 4 4 is 16. Then put x equals to 4 and y equals to 0. We get 4 3 is 12. Okay, this is maximum because they given maximize, so it is maximum. Okay, now therefore the objective function is maximum at point B. 0 comma 4 is 16. Okay, this is the answer. So have to solve up to this much. This is for 6 marks question. Okay, the first question, the first step is have to check the points for subject to the constraints. Whatever the given equation, for that equation have to take the points. For using these point have to draw a graph, then have to find the feasible region. If feasible region is bounded, then we have maximum and minimum value. If feasible region is unbounded, we don't have any maximum or minimum point. When we have bounded region or unbounded, so we have to take the corner points. For that corner points, we have to check the adjective function, it is maximum or minimum. Okay, up to this much have to solve. This is the 6 marks question. Okay, now we have to check the next question. We have to consider the question number 2. Minimize objective function z is equals to minus 3x plus 4y subject to the constraint x plus 2y less than or is equals to 8 and 3x plus 2y less than or is equals to 12. Okay, so first we have to take the equation 1, x plus 2y less than or is equals to 8. Have to take the values x, y. When taken x is equals to 0, so we get y is equals to 4, and when y is equals to 0, we get x is equals to 8. Again, I have to check the second equation, 3x plus 2y less than or is equals to 12. Take x, y, put x is equals to 0, so we get y is equals to 6. Again, take y equals to 0, x is equals to 4. We have points now. Okay, for this two equation we have to draw a graph. Okay, here I am taking a graph. I am already plot a graph here. That is, we have to verify now. Okay, we have to verify the points. So first have to check x is equals to 0, y is equals to 4. Here x is equals to 0, there is a point y is equals to 4. Again, the second point, when x is equals to 0, again we have take 6, the second graph. Okay, here graph of the second one function. Okay, the common region, when you take graph on graph paper, we get the corner point. This is the common region I have taken between the two graphs. Okay, this is the common region. So here there is a one coincident point 2 comma 3. Okay, there is a one coincident point 2 comma 3. So we have to take the corner points. Here the feasible region is bounded at corner points A, B, C and T. Okay, here I am taking the feasible region A, B point, C as well as at D point. Then the corner points, that is A is equals to 0 comma 0, B is equals to 0 comma 4, C equals to 2 comma 3, 4 comma 0. Now I have to find the value when x is equals to 0, y equals to 0. We get z is equals to 0. Again, when x is equals to 0, y equals to 4. I am taking x is equals to 0, it becomes 0. 4 into 4, it is 16. Again, 2 comma 3. These are the coincident points. Okay, again we get x is equals to 2, minus 3 into 2, minus 6. Y is equals to 3, 4 into 3, 12, 12 minus 6, we get 6. At point D, 4 comma 0, that is minus 12 is minimum. Okay, we want one minimum, therefore, okay, the objective function is minimum at corner point D, 4 comma 0 is minus 12. Okay, this is the minimum at minus 12. Okay, this is question number 2. Next question I am consider. Here there is a question number 3 in exercise problem. I have taken the problem indirectly on graph paper. So I have to solve now. First I have considered the equation, that is 3x plus, so wait, I'm taking this, that is 3x plus 5y is equals to 15. So for this one, x, y. Okay, here take the points, x is equals to 0, so have to solve y is equals to 3. 5 ones are 5 threes are. Again y is equals to 0, so 3x equals to 15. 3 ones are 3 5s are. Okay, we get the values. I am taking the second equation, 5x plus 2y less than or is equals to 10. Okay, x, y. Now here put x is equals to 0. We get y is equals to 5. Again y is equals to 0. We get x is equals to 2. We have two values for the graph. So I have placed a graph here. Okay, I am taking backside of this graph, that is we have only maximum point. we have the maximum point. X is 5 and y is 5. Okay, that is don't waste time in exam. Okay, this is the simple problem for 6 marks. So time is very precious because in this year the time was less compared to last year. 0 1 2 3 4 5 6 1 2 3 4 5 6 7. First I have to mention the scale. Okay, x-axis 1 unit is equals to 1 centimeter, y-axis 1 unit is equals to 1 centimeter. Okay, now check the point. Here there is a first point, that is for the first graph I have considered x is equals to 0, y is equals to 3. Here x is equals to 3, 0, y is equals to 3. Okay, now again x is equals to 5, y is equals to 0, x is equals to 5. So the first diagram I have to take the graph of this one and draw a line. Again for another one graph, that is taking x is equals to 0, y is equals to 5. X is equals to 0, y is equals to 5, and y is equals to 0, x is equals to 2. Here okay, the common region for both is the common region. This is the common region of the first one. Okay, I am taking the common region for the second one is okay. So the common region for both the graph is here. Common region for the both the graph is here. Okay, now I am taking the point, the coincident point here. Okay, there is a point. Here the shaded region is 1 2 3. Here there is a point. Okay, I am taking A, B, C and D. Okay, this is the bounded region, but we don't get exact position of this point. For that purpose I have to calculate the equation. Okay, I have to calculate the equation, that is 3x plus 5y is equals to 15. Again 5x plus 2y is equals to 10. So multiply by 2 here and multiply by 5 here. Okay, we get 2 into 3 6x, 2 into 5 plus 10y is equals to 30. Here 25x plus 10y is equals to 50. Now take minus, that is symbol will be changes. Subtract 25 minus 6, that is 25 here minus, that is 19x is equals to 50 minus 30, that is 20. X is equals to 20 by 19, that is 1.0. Okay, 19 ones are 19, there is a 1, then I am taking 1.0. X is equals to nearly 1.05, Again I have substitute x value in any one equation, then we get y value. Okay, so you have to take y value or calculate using simple calculator. Okay, using simple calculator or take any value in this equation. 5 into 1.05, okay, 5 into 1.05, that is 50 minus 5 into 1.05, 44.75 divided by 2, that is 22.37. Y becomes 22.37. Sorry. Wait, I am taking here. That is, okay, here I am taking x value here. 5 into 1.05 plus 2y equals to 10. Then 2y is equals to 4.95, y is equals to 2.45 something. Okay, now the corner points we have. Okay, that is, nearly I am taking x is equals to 1.0 and y is equals to 2.4. Okay, that is 4 5. So we have to check the corner points. Okay, the corner points. Before going to that, we have to write one point. The feasible region. The feasible region is bounded. The feasible region is bounded, and the corner points a equals to 0.0, b is equals to 0, x axis 0, y axis 3. Then c 1.05, 2.45, and d is equals to here z 2, 0. Okay, then objective function z is equals to, that is 5x plus 3y, 5x plus 3y, we get 0. Here 3 into 3 9. I am taking 1 and 2.5. Simply 5 into 1 5 plus 3 to 6. 3 into 2.5, 3 into 2.5, that is nearly 7.5, that is again 12.5, nearly 12.5. Again put x is equals to 10. Therefore the maximum is the objective function is maximum at C 1.05, 2.45 is 12.5. Okay, this is the solution of the given point. Okay, when you practice more, you will get easily by results. Okay, next another problems we'll discuss in next session.